All right, so here we are with Unit 3, Section 7, graphing inequalities with two variables. If you recall, when we graph a line using slope-intercept form, we want to make sure we have y equals mx plus b. Make sure the equation is in slope-intercept form. Second thing you're going to do is plot b on the y-axis because this is the y-intercept. From there, you're going to use the slope, rise over run, to plot more points. And then from there, you can draw the line. Well, now when we do inequalities in two variables, here's what's going to happen. We're going to put the inequality in slope-intercept form just like we had before, but this time when we draw the line, it will either be a solid line or it'll be a dashed line. It'll be a solid line if you have less than or equal to or greater than or equal to. It'll be a dashed line if it's just less than or if it's just greater than. The way I always remembered this was if there's a line here, it'll be a line on the graph, meaning a solid line. If there's no line underneath it, then it'll be a dotted line. No line means no line. A line here means a line on the graph. And then we're going to either shade either above the line or below the line. It's going to be above the line if it's greater than or equal to. It'll be below the line if it's less than or equal to. And here's what we mean by that. When we go to graph the line y is equal to negative 2x plus 3, like always, we're going to be starting at positive 3 on the y-axis. And because it's negative 2 over 1, I'm going to go down 2, right 1. I'm going to do that several times to be able to draw a nice solid line. And it will be a solid line because my inequality is greater than or equal to. So I'm going to have a solid line. Make sure you use a straight edge and make sure you take your line all the way across the graph. Now, take your pencil and put it somewhere, anywhere on the line. Now, it says greater than, so we're going to be shading above. So from the line, from where you put your pencil point, go up. This is the side we're going to be shading. So we shade this side of the inequality. And this is saying that any point in that shaded area will satisfy this inequality. When we do y is less than x minus 3, because my y-intercept is at negative 3, my slope is 1 over 1, so rise 1, run 1. But this time I'm going to have a dotted line because it's just less than. So I have a dotted line. And because it is less than, I'm going to be shading everything below the line. So what this is saying is that any point in the shaded area will satisfy the inequality. Now, here's the difference. In this problem, any point on the line will also satisfy the inequality. For example, if I use the point 1, 1, looks like it's right on the line. If I were to use the point 1, 1, this should come out to be exactly right. 1 is greater than or equal to negative 2 times 1 plus 3. 1 is greater than or equal to negative 2 plus 3. Negative 1 is greater than or equal to 1, which is a true statement. So anything on the line or above it is going to satisfy this inequality. But here's the difference. Any point on this line will not satisfy the inequality because this says less than. Let's use the point 3, 0. If I use the point 3, 0, I'll put the 3 in for the x and the 0 in for the y. 0 is less than 3 minus 3. Is 0 less than 0? No, that is a false statement. So any point on this line will not satisfy the inequality. So let's go on to the second page and see what we have there. Well, before we do anything else, we have to put this equation or the inequality into slope-intercept form. To do that, I'm going to be subtracting 3x from both sides. Leaves me with 2y is less than negative 3x plus 8. Dividing everything by 2, I get y is less than negative 3 halves x plus 4. I go to positive 4 on the y-axis, not the x-axis. Go on the y-axis. I'm going to go down 3 and right 2. Follow this pattern all the way down the page. And draw a solid line or a dotted line. Since it's just less than, it will be a dotted line. And I'm going to be shading everything below the line. In number 4, we have 2x minus y is greater than or equal to 3. So I need to subtract 2x from both sides. Leaves me with the opposite of y is greater than or equal to negative 2x plus 3. Divide everything by negative 1. We'll have y on the left side. We'll have positive 2x on the right side. We'll have a minus 3 as well. But keep in mind, since we are dividing by a negative, we flip the inequality sign. So I start at negative 3 on the y-axis, and I'm going to rise 2 and run 1. Down 2, left 1. I will be drawing a solid line. Take your line all the way across the graph using a straight edge, and we're going to be shading underneath. So any point in the shaded area will satisfy this inequality. Number 5, x is less than or equal to positive 3 will be a solid line. And if you recall, x equals 3 is a vertical line at where x is equal to 3. So here's the line, x equals 3. The only problem with this one is, though, that we can't do above or below, because above this line we just get more line. Below the line we get more line. So we're going to be shading right or left. And this is the only exception to an inequality that will be shading right or left. Everything else will be up or down. But on this one we go to the left. So here we have x is less than or equal to 3. Y is greater than negative 2 will be a dotted line at where y is equal to negative 2. There. It's going to be greater than, which means we're going to be shading above. So anything in the shaded area will satisfy this inequality. Again, this is Mr. Bouchong in Algebra 1 with Lake Central High School, talking about graphing linear inequalities.